If I ask you to solve these missing number problems, you will intuitively see the pattern. For the first one, we clearly see that the numbers decrease by 2. This is a linear pattern, and our answer is negative 14. For the second one, the numbers are increasing. Though they are not increasing by a constant value, it is easy to find a pattern in the differences. The differences are 1, 2, 3, 4, 5, and so on, which are increasing at a constant rate. This is easily recognizable, right? We get an answer of 24. This is a quadratic pattern or values from a second degree polynomial. But when we move to higher degrees, the patterns are not that intuitive, and we need a proper step-by-step approach to find the degree of the polynomial as well as the missing number. So let us find the answer to this missing number problem given that these values come from a polynomial. We have to keep on finding finite differences until they become constant. The finite differences are differences between consecutive values in this sequence. We start by finding the first difference. It is not constant. We then find the second difference and then the third difference. The third difference is constant, so we finally stop the process. We conclude that this is a third degree polynomial sequence, as the third difference has come out to be constant. Now we start with a reverse calculation. The difference between consecutive terms of second difference series is 6. So the next number in the second difference series is going to be 14 plus 6, which is 20. The last second difference is 20. So the next number in the first difference series is 24 plus 20, which comes out to be 44. And finally, our missing number will come out to be 37 plus the last value of the first difference, which is 44. 37 plus 44 equals 81, which is our answer. Now here comes a challenge for you. Let's see if you can solve it. Bye.